screen options. Screen share. Now. Here, finite automata is the most important language into the computer science. The discrete mathematics total tools that how we will be converted in terms of computer science, that is called as a mission level language. So the mission level language, mission understandable languages, how we will be given into the system, that is the most important tool. And the strings and alphabets, how we can be defined, and regular sets and regular expressions, how we can be given. That is a finite set of missions, mission, how it should be understand the language. The total things we can be discussed in this finite automata. And 13 unit 14, 15, 16, total it is a theory. Here you should write into the proper learning, and directly you should be write into the examination. That is a total algorithm. That is a mathematical theory. How the simple class of algorithm way we can be write into the computer systems. That is a called as a finite automata. Finite automata. This is the total information we can be studying this finite automata theory in the basic details, basic definitions, ideas of users of the finite automata, the things we can be learning in this unit. In this introduction part, it is a plural automata is a mathematical model for the finite state machines. Finite state machines means FSM. That is a standard form is the FSM. The plural automata, automatic. This is a finite automata, but the first studied by the Stephen. It is in the year of 1950s and found the number of applications into the computer science. He developed that is many things into the computer science in this period of the 1950s. And he used that is a design of the computers circuits, and it is a logical analyzations, everything we can be in the one tool he used that is a lexical analysis of the compilers. Such things he discussed. At the time, lexical means it is something it is incremental order. How we can be get the quicker analyzation, the things they discussed in this period. The later on that theory, the development of the mathematics in the 1960s and 70s, and the eminent mathematicians.
Sir, your voice is not audible, sir.
Voice is not audible. 1 second. Thank you. Now here, sorry, Amma, now voice is audible. Now voice is audible, Amma.
Yes, sir.
Okay, fine, thank you. Now here, computer the mathematicians. It's the great mathematicians. They developed the tool of this. This is analyzation of the automata theory and mathematics, interlink connectivities, how the machine level languages will be understand. Such a things they have given in this period. In this, Stephen Kenley, he found that is automata theory for the 1950s. He used that is in the computer applications. In that particularly, it is the design of the computer circuits and lexical analyzations and compilations point of view used that. After that, it is many mathematicians they are developed and eminent mathematicians. It is Samuel and Ellen Berg and Marcel Paul and Sedge. It is a Berger and the John Red is, it is, they are the main, mainly they applied that is automated theory into the computer science. They are the mathematicians, how it will be useful into the computer science. They elaborately they mention. This is the most important aspect we know. Then after that, it is the terms of the finite automata describes in the class of the models of the computation that are the characterized by the having the finite number of the states. It is a various places how the computational it is a model is a characterized. That is the information we can be studied into the finite automata descriptions. In this consist of the finite set of the states. It is a finite set of the transient rule for the changing from the one state to another state. It is a one state formation, how it will be the changes to another state formation. It is a machine level language is converted to the our system understandable language. So that is a conversions of that devices, how it will be the establishing into the device should be understand how the conversions, the total the concepts is some of the information we can be study into the finite automata description. In this example, if I take that is the one state, how it will be the converted into the another state it is a thermostat is a finite state mechanism. It is mission, which is a two states of on or off. On or off system is called as it is a thermostat. In that thermostat is a two transient rules. It is a measured as a temperature is a less than that the set temperature. It is a switch from the off to on. The measured temperature is greater than the set temperature, then switch from on to off. This is the assumptions that only the one transient rule can be the valid at the time. The above system is a finite state mission, FSM, can be represented by the state diagram as follows. It is a measured temperature is less than set temperature. That is whether it is a less than at the time it is a half, or it is a greater than it comes to the, it is a, whenever it is a off to on conversion, it is a measured temperature is less than some temperature. When it is a on is I want to make it to the off at the time, measured temperature is greater than set temperature. Automatically it will be the on off system can be working. Now present days it is a Google system also. It is a lights I want to off in that room by giving that is this voice. That voice is converted into the machine level language that automatically it will be going for that's on or off. That kind of the tube lights and bulbs also is available in the market. So that kind of new conversions of the states, it is a measured based on the voice. There it is, I use it with the voice. Here they are using that is a measured temperature. Temperatures, it is a less than as a set temperature. Automatically it is off is going for the on, and on is converting into the off. It will be the measured temperature is greater than set temperature. That automata they use that kind of the relationship. Present it is a technology highly developed, so that it is a this conversion. So they use it into the conversion to the voice conversions, modulation conversions. So that automatically modulation conversions and a device supply support systems. So they develop that is that mission level languages. So they use at advanced levels of automata. This is our overall idea about it. What we have to be convert. What we should be learn in this. What the system is available that the automata. What is the automata will be the one state to other state. How it will be off state to on state. I am converting. This is our main advantages of this automata. It is a discrete mathematics tools are the we want to be apply for that is on or off systems. So devices I want to apply at the time it is will go for the on and off system. So one level of the mission system, how it will be the converting to the another level of the system. That is the most important tools we are the using here. One of the assumed that it is a storage devices here. How the financial state mechanism, it is a missions are the assumed to the how the storage devices. It is consisting of the unlimited numbers of the cells, each capable of the holding a single symbol from some alphabet. At any given the time, as an FSM is in a certain internal state reads an input and sends an output, which is depends on its internal state. And input and then the changes its internal state on continuous into the same state. That is also one kind of the observations we can discuss here. Special kind of that it is a FSM called as a finite state acceptor. It is it can be the recognize the strings of the language. This is a different from a regular FSM in the sense that it does not is a produce output. It will be have that is a few states as a acceptable or finite state. It means that it is a one state it is not acceptable. It will be converted into the another kind of this Now, in this discussion continuation, Amma, voice is audible?
Yes, sir.
Please respond, anyone.
Yes, sir.
Voice is audible?
Yes, sir.
Yes, sir.
Hello?
Sir.
Yes, sir.
Hello, my
Break
voice is audible?
సార్ మధ్యలో బ్రేక్ అవుతుంది సార్.
Hello?
సార్.
Hello?
సార్.
Hello?
సార్ వినబడుతుంది సార్.
My voice is audible?
Yes, sir. Yes, sir.
Okay, thank you. Okay, fine, Amma, thank you. Now here, in this basic information I have given, that is what is the automator. Now, before మా స్క్రీన్ కనిపిస్తుందా?
sir.
Okay, now it is a we will I mentioned that it is a mathematics for the symbols and strings and formal languages and regular expressions we will discuss here. Symbols is a abstract entity. Abstract entity. What we should give, that is called as abstract entity. In the title heading, what we are to mention, that is called as symbol. Here is the as per the it is a terminology of alphabets. Next, letters and digits are examples of the most frequently used the symbols. See here, alphabets is a finite non-empty set of symbols. Alphabet means it is a finite non-empty set of elements. Hello, ma. Here today, your sister. Okay, okay. Hi. Mask. Same.
Almost.
ID card. తీసుకున్నావు?
పర్మనెంట్ ఇవ్వలేదు సార్.
ఓకే, పర్లేదు, అలా చేస్తారు.
ఎలా చేస్తారు?
అలా చేస్తారు. దీనికి ట్యాగ్ తీసుకోపోయావు?
దీనికా?
ట్యాగ్ తీసుకోండి అక్కడ వాళ్ళతో ఆఫీస్ లో తీసుకోండి.
దీనికి కూడా ఉంటుందా సార్ ట్యాగ్?
అవును, అంటే దీని అదే నార్మల్ది ఇలా తీసేసుకుని వేసుకోవడానికి ఆఫీస్ లో ఉంటుంది. పైన మేడం ఉన్నారు, ఇది మన స్టాఫ్ రూమ్ లో మీ మెంటర్ మేడం అడిగితే కింద ఆఫీస్ లో ఉంటుంది, మేడం తీసిస్తారు. ఓకే, ఇది బి కేర్ఫుల్ అమ్మా. ఇది లాస్ట్ స్టాంప్ అయిందా? అది రౌండ్ సీల్ స్టాంప్ ఉందా? ఓకే ఫైన్, వాల్యూ
ఇప్పుడే తీసుకున్నాను సార్.
ఓకే, ఎగ్జామ్స్ బాగా రాసాయి, అన్ని క్లియర్ అయిపోయినా. ఓకే ఓకే మ్యామ్, జాగ్రత్తగా వెళ్ళండి. నెక్స్ట్, an alphabet is a finite non-empty set of symbols. It is generally denoted by the summation. Summation equal to 0, 1. Binary set of the 0, 1. Set of 0, 1 is a binary alphabet. Binary alphabet. Summation equal to a, b, so on z is a lowercase English alphabet. Lowercase English alphabet. These are also one kind of the symbols. That set of all the elements, small letters, is we called as a alphabet. It is denoted by the summation. Summation antene oka alphabet. Adi gurtu pettuko. Bracket of a, b, so on z is a lowercase English alphabets. It is a summation is a one symbol for the alphabet because of set of elements. Next is the summation is called as a, b, so on z. It is a capital all letters. That is also one kind of the set of elements. Here I want the only 4 numbers of elements. That is called as the alphabet. It is a set of a bracket of a, b, c, d. Here binary alphabets means 0 and 1. It is a on or off is also we can denote represented by the zeros and ones only. So bracket of 0, 1. It is called as a one symbol. That is a summation is called as the alphabet. That you should be remember. Next is called as a string. String or the word. Usually we use that as a word. That is a previous. That is mainly used as a string in the computer terminology. That string is a finite sequence of the symbols. It is a juxtaposed. That is we call as juxtaposed, and from the some alphabets. It is a string means it is a we can write as a A B C D. After that B A C like that. It is a how the elements is a continuously it will come. Here continuously it will be the 4 elements, it will be the repeated. 4 elements, it will be the repeated. That is a finite sequence of the symbols. That is called as a here which order we want to be get it. That is the order. So if we mention that is comes to the here finite sequence of the symbols, it is a just a pose from the some alphabet. That is called as a string. That is called as a string. Now here if a, b, c, d, a, b, c, d are the symbols. A, b, c, d, b, a, c is the string. One of the string. That is you should remember. The length of the string is x is defined as the number of symbols and composed the string and is denoted by hello. ఎవరున్నారు పక్కన మేడం ఉన్నారా? ఒకసారి ఎవరు చిన్న మన దాంట్లో కింద డెస్క్ లో కింద డెస్క్ లో చూస్తారు పక్కన అవి ఒక ట్యాగ్ అంటే వాళ్ళు వేసుకోవడానికి మెల్లు వేసుకోవడానికి ట్యాగ్ ఒకటి తీసుకురా వాళ్ళ సేమ్ బ్రాంచ్ ఉంటుంది ఒకటి తీసి ఇచ్చేసారు ఓకేనా now it is a null string or an empty string or the empty word is a string with the no symbols and it is denoted by the epsilon or lambda. Now it is a note, it is a mod epsilon c is a sometimes it is a mod lambda equal to 0. What happens? Lambda equal to epsilon equal to 0. What happens? This is a nothing will be there in the string so that it is comes to the null string. Null string. Here previously it is a string length is denoted by the mod x. Mod x. Mod x means it is a how many elements we have, that is a total will be represented into the mod x. That mod x means it is a number of elements, how many we have. That is called as it is the length of the string. That string is no elements will be there. That is a mod lambda or mod epsilon is equal to the 0. Next, prefix or the string is any number of the leading symbols of the string, and the suffix is any number of the trailing of the symbols. The string is a ABCD has the prefixes and the epsilon A comma AB comma ABC comma ABCD and its suffixes are the epsilon D CD and BCD and ABCD. These are all called as the prefix and suffixes of the string. Suffixes of the string. Other than the string itself is called as a proper prefix or the suffixes. That is a proper suffixes or prefixes. Prefixes means it is clearly it is incremental order for the epsilon. After that A, B, C, D, A, B and ABC and ABCD. See here one by one it is incrementing. Epsilon means nothing will be there. And A. Empty set, I am taking the epsilon. Then after one element is A and two elements are there, AB order, it is coming that order. And ABC, the third order, and ABCD, it is a fourth order. That is called as a prefix. And suffixes means it is a back to it will come to the end. It is a D first, it will come. Then after that, the previous one will join it to the left only. That is a CD. Then after that, again, it will be joined for the BCD. And other is a ABCD. Like that, it is at the end of that, it is a prefix and suffixes must be the same, but it is a string is coming to the, it is a previously, it is a from the left to it is right or right to left, it will come. That is coming to the prefixes and suffixes will be the differentiated to the proper prefixes or suffixes. Next, it is a definition. It comes to the, it is a concatenation of the two strings is the string formed by the writing the first followed by the second and with the no intervening spaces. That is only two strings. That it is a two. It means that is a two strings. It is a writing the first followed by the second string, and with the no intervention spaces we should give. That is comes to the concatenation. Concatenation is the one of the pet. That is a name is called as a pet name of the it is a concatenation of the pet and the name is a pet name we call. Here it is a juxtaposition is used as a concatenation operation. Juxtaposition, if we call as it is called as a concatenation operation. Example, x and y. If x and y are the strings, then xy is called as a concatenation of the x and y. It means that is a mixing of the both. It is a some string into the another string. It is comes to the concatenation. That is a pet names we call as it is. I mean that is the two strings are the one string is followed by the another string. That is one string is a set of elements is added to the another set of elements. That is comes to the one of the concatenation. The empty string is identify the concatenation operation. It is epsilon x is equal to x epsilon equal to x for the every string x. And the properties of the string is if epsilon is the alphabet and we denote that is a set of strings obtaining by the concatenating the 0 or the more symbols. It is a summation or the summation star. Thus it is a that is one of the string another strings. It is a two strings I want to be. One string is depends on another string. What happens is if summation plus is a one string, it is equal to the summation star minus one of the element I am removing from the epsilon. That is comes to the one of the new kind of the operation. That is come to the another properties. It is mean that is a concatenation 1 0 and more symbols are there. Hello ma. Me will me branch will leave. కానీ అక్కడ మీకు వేరే బ్రాంచ్ మీ బ్రాంచ్ వాళ్ళందరూ ఒకటే కలర్ ఉంటుంది కదా. సర్లే తీసుకోండి వెళ్ళండి అవసరమైతే యూజ్ చేయండి లేకపోతే అవసరం ఓకే The empty string is the identity for the concatenation operation epsilon x equal to x epsilon equal to x for every string x. And the properties of the string is epsilon plus is epsilon star minus epsilon. That is one of the examples. These are the in your examination you will ask these kind of examples. If u and v are the any two strings of epsilon star, then it is a mod uv is equal to mod u plus mod v. We define the length of the string is recursively. It is a mod a equal to 1 and a w mod wa equal to mod w plus 1 for all the a is belongs to epsilon and w is belongs to epsilon star. What is that epsilon? It is the one string and another string is coming to the epsilon star. So it is two strings I am concatenating. So that length of the strings is a recursively. It is I can take the mod a. Mod a means it is a length of that. Like only one element will be there. So that it is a mod a equal to 1. Another string it is going for that. It is also it is a mod w plus 1. That is a w is we called as a clubbing of that. So that it is mod w plus 1. For all the a belongs to epsilon and w is belongs to the epsilon star. The means of that length of the string single symbol is 1 and the length of the any string is increasing by 1. If we add the another symbol to it and prove that is a result of the induction and 14.1 holds that it is a above relationship. No. చూడండి అది స్పెసిఫిక్ బ్రాంచ్ మీరు బయట యూజ్ మీరు బయట యూజ్ చేయడానికి పనికి వస్తుంది ఎగ్జామ్ ఊరికే పెట్టేసుకోండి ఓకేనా అంత పెట్టేస్తుంది జస్ట్ ఇలా పెట్టేసుకోండి అలాగే పాడైన ఓకే ఓకే ఎగ్జామ్స్ బాగా రాయరా అన్ని పాస్ అయిపోవాలి వస్తుందా ఓకే ఆల్ ది బెస్ట్ బై here it means that is the length of the single symbols is a 1 and the length of the another string is increasing by the 1 if we added the another symbol to it. This is a oral idea. If it is a simply here you can check it the length is all it is a one thing we should be observed. It is a mod uv equal to what is that mod u plus mod v, no? So that it is a length is all the both the lengths will be added. That is string one length is a mod u, another string length is a mod v. Though it is a when we added that is all the strings it will be the both will be the same. Similarly here we can be used that is your mod v is equal to the mod w equal to mod w plus 1. So that it is a mod uv equal. These all are will be coming to the induction hypothesis. So that it is a mod uv is also mod u plus mod w plus 1. Because of mod v, I'm taking mod w plus 1. So that it is automatically mod u plus mod v only. So it is hypothetically we can say that it is both mod uv equal to mod u plus mod v for the any strings. It is u and v are belongs to the it is epsilon star. Epsilon star. That is that is also epsilon star is another string. So your concatenation rule as based on that, we can say that it is a u and v are the any two strings of the summation star is then mod uv equal to mod u plus mod v. That is the overall idea. If s1 and s2 are the two sets of the strings from the epsilon star, then the concatenation of the s1 and s2 denoted by the s1 and s1 s2 is the sets of the bracket of xy such that x belongs to s1 and y belongs to s2. That is the strings in s1 and s2 are the formed by the choosing a string in a s1 and the for combinations. If S is the set of the strings from the epsilon star, then the Kelling closure, we call as the Kelling closure, set of strings from the epsilon star. Then the Kelling closure, the simple closure of the S, it is denoted by the S star. It is the unit of, it means that is a, here coming of the union of the sets. If I take, what happens? That is called as S star. That is developed by the Kelling closure. S star is equal to the union of I equal to 1 to 0 to infinity is a S power I. That is a S1, S2, so on. All I am adding. That is called as a, it is a Kelling closure. It is a, yes, a circle is a equal to the bracket of epsilon. That is equal to the, yes, I equal to S into S power I minus 1, I greater than or equal to 0. Positive closure, if I take the S, it is denoted by the positive closure. Here also we can say that This is S plus is equal to the union of I equal to 1 to infinity S power I. Next here examples, if I take that is a 10 comma 1 is a two strings here we have. That is a 0 1 1. Another coding here 1 0 1. I am taking that is a one string for that. It is a S2 is a 0 1 1 comma 1 1 is a strings. It is a what is the digital code is the binary code is converted into the another kind of the system. That is then it is a S1 S2 is a concatenation S1 and S2. I can take that here S1 is to clubbing up that it is a, how many possibilities we have 1 0 after that 0 1 1, so that it is a 1 0 0 1 1. I'm adding that is all the word is a one word I'm taking it comma 1 0 1 1 is the second one. Then it is a 1 0 1 1 and 1 1. Just it is a concatenating all these things. It is a coming to the holiday repetitions we should avoid. So that is the another set of elements. So that it is a 1 0 1 1 and a star. It is equal to the another kind of the set of elements. Like here we can concatenating that is a S1 and a S2. Here S1 S2. He will ask that is a question. S1 he will give and S2 will give. Then find out the S1 S2 means here we can go for that is a below example. If S equal to bracket of epsilon, then it's obtain the S star. By S equal to bracket of A, it means that is only we have a one single element, so that it is a obtain the S star and S plus. Here S star we can go for that is a XA power R. Is the string is a recursion as far as that it is a power R equal to what is that A only. Though it is a XA power R equal to A X to the power of R. For all A belongs to F summation and X belongs to the summation star. These are the observations we can check. Now coming to the languages. Here grammatically what kind of the languages we have strings and alphabets, how will be the established the set of elements groups, the things I explained just now. Now coming to the languages, it is a usually natural languages. It is a possible to the state the well-defined set of rules of the we called as a syntax by which is a formal language can be constructed. These formal languages such as a programming language are used to the communicating with the mission level languages, the original language, the communicating with the missions, communicating with the mission. We are writing that is the strings all will be the it is coming to the mission level language that will be converted into the programmable languages. So it is interconnectivity between these two are the more important aspect of this automata. In order to the generating that is a valid sentences of the formal language, it is decided whether the combination of the words it is the valid sentences such as language. In the forming of this grammar association of the language, it will be the simple language. Simple languages we should be understandable languages. We should be converting into the our alphabet manner. That is a finite set of alphabet we have to be taken here. Languages are the letters of the capital with the without a subscripts. It is a below is the notation is a phi is a empty set. Phi is a empty set. It is a set consisting of the empty. Hello, hello. May I know who is speaking, sir? Tell me, sir. Regarding, sir, please, sir. Yes. He mentioned in the last the 4 months back. Okay. Tell me, sir. When you are shifting here, Hyderabad. Okay, fine. Okay, fine. Here, how many members will stay, sir? Okay, fine. How much you are expecting? You can spend. Okay, you want double. Okay, sir. I will identify and I will tell you, sir. Can we have it that is a 1 month period? Okay, sir. Okay, sir. I will find and I will inform you, sir. Where do you stay, sir, presently? Okay, fine. Sir, I will call you in the evening, sir. It's no problem, no? Okay, sure. I will help you, sir. No issue. He's my best friend. Sure, sir. Thank you. Now here he is asking that is the set of non-empty. It is a note point we have. It is a Malayalam is a one word is I'm taking one word Malayalam. Refer Bob and 1001. These all are the palindrome sentences. See here, what is a palindrome? It is a middle left side. What are the words we have? And the right side also we have the same kind of words. M, it is a left side is there and right side also same. Afterwards, it is A. Before and after that, right side also. A, L also, and A also, and middle is a Y. So that is called as a palindrome. Refer also it is a palindrome. Bob, B-O-B, Bob. It is the middle is a O, and the right and left is also these. And then it is coming to the 1001. What happened? It is a here 0 beside 0 and 1 beside 1. So A, B, A, it is a even number. So that odds means it is a center will go to the different number and coming to the sides are the same numbers. This is called as a palindrome. That is also one of the string. One of the string. Next, it is coming to that. It is a palindrome over the alphabet 0, 1 is a infinite language. Some members of this languages are the epsilon, 0 and 1, 0, 0 and 1, 1 and 0, 1, 0. Here, examples, it's a letter. It is a if I take that it is epsilon is equal to the bracket of A comma B, then epsilon star is equal to bracket of epsilon comma AB, A comma B comma A comma AB comma BA comma BB comma AA comma AAB. This is the kind of the sentences into the some kind of the language. So that languages we want to be show into the representation form means I will take the one set L is a sentence L I will take that it is a combination of the letters L that is a set of elements of A and B and AAB. It is a language on the epsilon. Since it is a the set of set is a finite. It is a finite language. So the set L1 equal to bracket of A power N B power N such that it is N is greater than or equal to 0 is called as the language of the epsilon. The string is the AB and A and BB like that. It is coming to the theoretically how we can be defined L1, L1, L2 is equal to XY such that it is X belongs to L1 and Y belongs to L2. Like here you can read L plus means that all the union of all the set of languages I can be added that here that is a one sentence is a continuation of the another sentence I can be added. These are the total information about that languages. So that languages, the examples also we have due to the time factor. I'm going for the important aspect. Next, it is a regular sets and the regular expressions. It is a regular expressions. It will be go for that. Is a final set of the words is over the epsilon, and it's a regular set. Finite set, including empty set is also available in that. That is a finite set of the words is called as a regular set. The S1, S2 are the two sets I'm taking the regular sets. It is a over that it is S1 union S2 and S1 S2 are the also the regular. If S is a regular set over the epsilon, then the closer S star is also with the regular. No set is a regular unless it is obtained by the finite number of the applications defined for the rules of the 1 and 3. 1 and 3 means it is a regular set and closer to the star also another regular set. So both will be the one conversion to another conversion. So both will be the mixed. That is the condition number 3. And both will be the concatenation. It is coming to the 2. And it is coming to the 1. It is a epsilon is a regular set. It is at least elements that the available or not. These are the things if we happen that which set is not regular and regular that can be defined. And it is a set of elements of expressions are the summation. It is the R1, R2, the regular expressions. Then R1 union, I can take it. R union means it's a plus only. Concatenation of R1 and R2 means it is a product also. These are the expressions we can be used in the regular expressions. R and R stars. Here, regular expressions we can be used. Next, coming to the here. Pi is a regular expression and denoted the empty set. It is epsilon is a regular expression denoted with the set of the epsilon. And A is a regular expression denoted with the bracket. Regular expressions are used to the some of the simple languages. It is R1 plus R2. Here we can check. It is the L of R1 plus R2 equal to L of R1 plus union L of R2. L of R1 into R2 equal to L of R1 into L of R2. L of bracket of R1 equal to L of R1. Like here, R1 star is inside is a set of all the elements of the
will be there. Next, in the descript language, he will ask. So it is a star dot a plus b. That is a L is there. That is I can apply the both. Then after that, the union I can write it. Here L of a is equal to what is that epsilon of a that will be command a b is there. So L of a b. So the two elements. The combination of both concatenating that it is epsilon into a is equal to a and a and a like that. It is a combination. So we can be get it. This is a language for the how the expressions we can be represent. Describe the language of L, A, B star into A. That is also this is the bottom we have given the example. Next, regular expressions. How A star will be the language. The regular expressions are equal to A star into B power star. The total expressions pi plus R equal to R and theta R pi R equal to R pi equal to pi like that. It is these all are the expressions we have. Next. Arden's theorem is the most important. It is a we called as a in the division algorithm in the some other area division algorithm we call. Now here Arden algorithm for the because of here we are using in the language. He mentioned in the language formation so that it is called as a Arden theorem. In that Arden theorem, let P and Q two regular expressions over the alphabet epsilon. If P denotes P does not contain that is epsilon, then the equation R equal to Q plus RP. That is having that is a unique expression R equal to Q into P power P star. Here consideration of it is a division algorithm R equal to Q plus RP. That is a standard you should remember. Next RHS I am taking Q plus RP. That Q plus RP I can write as a your representation of if I use the R instead of R, then it is a Q P star P, so that it is a set plus it is a P star into P, so that it is a P Q P star QP star equal only we can get so that it is a R only RHS. RHS is given to the LHS. That is when we consider that the R equal to QP star. And QP star is the R we have considered, means it is called as a solution. We have a unique solution so that it is a R we can write as a QP plus Q plus RP so that I can substitute here. Q plus RP is a unique means it is that is I have to be substitute instead of R. So Q plus RP if I substitute I can get that is a QP plus RPP P square. So that it is expression we can write as a Q of epsilon plus P square plus RP cube. Like it is a representation, we will come into the one of the geometric series expressions. So that it is a geometric series expression is Q of epsilon plus P square plus so on P power I. So it plus R P power I plus 1. This is a Q R equal to Q of epsilon plus P square plus. So this is a total expression form. It is clearly we can write as a Q P power K expression. So this is a representation is clearly having that is a Q P power star P star. P power star. So that is R is a and Q power star is represent the same set. Therefore, the solution we call as a solution is a unique. Next example, if we prove that, he will ask like this: it is a 1 plus 0 0 star 1 plus it is another is having the product. So like that, it is equal to the right side expression. So here, if I take the left side expression, that left side expressions we should be converted into the form of right side. It is a what are that is a properties we have. That properties are the bottom above we have that these are the properties, regular expression properties. That regular expression properties based on that this will be converted in terms of your single formations. Where are that one second? Yeah, these are the expressions we can be converted into the form of see I will use it as a using that is a 11th expression so that 1 plus Q star it is mixed with the common I can take so that I can operate this. So using that I can give it to the product of these two. So that it is a PQ star power Q power star, I can get it that is the expression. So like that, it is a expression. So above rules are based on that. This expression can be changed into our form, solution form. This is a LHS equal to RHS. We can be say that. Next, similarly, it is a set of regular expression. 1 star 0 is a what is the 1 star 0? It is a 1 means it is a 1 1 1 1 1 1. This is a 1. Then star means it is a star 0. So that we can get this one. 0 plus 1 power star equal to bracket of 0 comma 1 star, so that this is the one kind of expression. Like here, these are the problems that are important for you. And the regular expressions, it is we can put that is a set of string set notation is the 0 star plus 1 star power star. It is called as a one kind of the string set notation. So it's a describe the languages for the A star and B star. So it is a RB, the regular expression is denoted by on the epsilon equal to bracket of A comma B determine the languages of L of R. L of R. So that it is a, we can go for that where R equal to A plus B power star into A plus AB. So that here L of R equal to L of A plus B star and A plus BB. So that A plus B star plus L of AB, that separation I can take. And the separation I can take and the union I can take. So that it is a product I can take. This is a oral idea about it. Next, similarly, we have any examples. Next, it is a two regular expressions. Single expression point of I discussed there, and two regular expressions can be said to be the equivalent if it is denoted with the same language. For equivalency, we use that as a symbol is a triple equal. So that expressions we can be taken to the below bottom. This is the most important. Is R plus R2 star is equal to the R1 power star into R2 star whole power star. So that is the L of R1 plus R2 whole power star equal to L of R1 plus R2 whole power star equal to L of R1 union L of R2 whole power star. It is a separation of these two. It is a whole power star is I can apply. It is a separation. So that is the representation of the R1 plus R2 star is equal to R1 star into R2 star. This is should be practiced. Then it is a coming to the 14.8.18. It is also R power star whole power star is equal to R power star. That is a simple L we can be apply and power strings of the above properties I can be applied. Next, the final state mechanism, it will come to the denoted by the capital M. That is the final state mission. Final state mission means it is a FSM, that is a capital M. It is a representation of the pi tuples. If I can take the number of tuples. Here, if I take the pi tuples, I can get the Q summation and the delta and the epsilon and O. So that Q is a finite set of internal state, and summation is a finite set of the symbols called as the input alphabet. So that O is called as a finite set of output symbols. Delta is a Q plus Q cross summation is a tends to Q is a transient function. So that it is a epsilon is a Q star. Summation is tends to 0 is called as a mission function. FSM is a useful, usually it's represented in the compact from either by the means of the table called as a transition state. This is a diagrammatic called as a transient state diagram we call it. It is a representation is being like this. It is a, we can see that this is called as a transient state diagram. How the it is the expression will be the connected with the both of them. Your friend asked that it is the previously, sir, how it will be the connected in the last class. One of your friends sent a message. Sir, how it will be the connected from the one set to another set? Here already he knew that is in the connectivities in the expressions of capital M is a finite state mechanism. What he has given capital M, it is a Q summation at delta and is epsilon O he has given. And Q equal to what we can write the bracket of U Q star Q naught comma Q1. These are two elements he has given. Summation we have a two elements AB and O we have elements of the 0 and 1. Delta, we have a connectivity between that is a delta of the Q naught comma A. What if it that it is a Q1 and B it is a Q naught and a Q1. Like that, it is a one connectivity with another connectivity. That is a boxes we can be represented into the Q delta star and what way it will be connected. Here, what way it will be connected means it is a Q star with the A, that is the name of the Q1. Q star with the B, Q naught. Here Q1 with the base of another A is a Q naught. And Q1 and B is a Q1. So that it is ABCD, it's a 1001 represent. That is called as a state table. When he will give that is the elements, at the time, Q summation delta and neta and O at the time that all the elements we should be take that 5 elements and corresponding table construction is called as a state table. Here, your friend asked that it is a sir how it will come to the A into B power star. That is a representation of the expression, so that it is a connectivity when it will be taken into the one into the another one. At the time the tabulation it will go for that. How it will be the Q star in connected with the A. That is I'm taking the delta, so that it is a delta of the Q naught into A is equal to how much Q1. So that representation of the bracket is a Q naught to A is a Q1. Now that is if I go for that is a transition diagram, state diagram. What happens? You can check here. Q naught is an initially state, that is a starting state, and Q1 is a starting state. When it will be the connected, it is a Q naught to Q naught. It is a what is it Q naught to Q naught? Nothing will be there, so that it will become that is O only. So that representation is showing that it is a B is a 0, and another is a 0 is also the 0. So that it is both will be the connected and A comma 1. It will be the Q0 to Q1. Q0 to Q1, when it will go, here A is there. Q0 to Q1, it will be the A is there. And another is we can go by the 1 also. Here Q0 to A, it will be the 1 only. So that it is a connectivities we have, that is a here Q0 to Q1. If I want to go, then I have a connectivities, it is A comma 1 only. Next, it is a backwards, it is coming to the Q1 to Q0. It is a connectivities are the A comma zeros. That is a representation. Itself, it is a representation of the B, so it goes toward the B comma 1 only. That is a Q, so Q1 to Q1, it will be represented. It will be the B only. So you see here, Q1, when I can get it, Q1, it is a B only. So that B. And Q1, it is a connectivity, it will be the last, will be the B only. So B, it will be connected with the 1 only. So that it is the representation itself only. Here, similarly, it will go for the connectivities of the Q1, Q0 itself. This is called as the initial state. How it will be, the diagram will be represented. Next, following the sequential of arrow diagram, that is above one is the arrow diagram representation is the output. How I can be get it? That output is it will be the FSM. It will be the represented that to the one state. It is a left to right. How it will be go ahead. That is a simple representation is a final state mission. It will be the automata will be the converted to the starting to ending. That will be the representation is clearly we can observe from the state diagram. These are the things. It is a DFS means it is a deterministic finite state automata. DFS, it is a clearly it will be the operates the one system of the manner. Operate the one system in the manner that is denoted by the quantuple. That capital M is if I take the particular type here, we have to go for that is a capital M equal to Q epsilon. Q is a first, then epsilon is the next, then delta is the next, then Q naught is and it is a one order if we mention that is called as a deterministic finite automata. One order if we particularly if we mention that is comes to the deterministic finite automatic DFA. Next, it is a non-deterministic. We will go for that. It is there is no any order. It at the time it will I can use it is a capital NDFA. It is a non-deterministic finite automata. Examples of these are the here consider that is a DFA capital M equal to Q0 comma Q1 comma Q2. That 0 comma 1 is a delta and Q0 into Q1, where the delta is given by the delta of the Q0 comma O, it is equal to Q0, and delta of the Q0 comma 1 equal to Q1, and delta of the Q1 comma 0 equal to Q0, and delta of the Q1 comma 1 equal to Q2. And delta of the Q2 comma 0 equal to Q2. So the delta of the Q2 comma 1 equal to Q1. That is comes to the one of the state. How initial state will be taken to the final state. That is a Q0 is the initial state and Q1 is comes to the final state. That is based on the DFA, deterministic finite automata. So that is a constant graph based on that is above given conditions. Here I can represent that is a graph also the same procedure. This is the overall idea about it, how it will be, DFA will be work on it. It means that it is a, power will be the, go for the one of the character to connectivity, like that is a, only the observations of the FSM and it is deterministic finite automata and non-deterministic finite automata. The total theory will be there, that is in that he will ask one question. Okay. Similarly, here we can go for that. As next is coming to the last is will be there, summary will be there. That state summary. The summary, what I learned means it is a basic concepts of alphabets and strings and language, regular expressions I discussed. And in that finite automata, how it will be connected. Finite automation, finite state missions, how it will be there. And a deterministic finite automata, how it will be connected. That total concept. Non-deterministic means how it can be separate that set of elements. The total things we discussed here. Now, if I go further, is another unit, and is a finite automata of the two, finite automata of two. It is a what is a non here I will focus on that. It is a non-deterministic finite automata conditions. What are that? And the equivalence of the DFA and that is they decide and minimum of the that is the tuning of the missions how I can be observed. That is these things I can be learned into the finite automata theory. Here these things we can be learned here one by one concept. It is we have due to less time. I am going that is this introduction part you can be learn who Michael and who Robin and Don Scott in the 1959 they developed for the DFA and NFA. it is a non-deterministic finite automata DFA in the finite state missions, and a DFA, it is a determined finite automata. These things will be the mainly it is focused on that Michael and Overhoven in the 1959 onwards. It is we have plenty developments in the power sets developments on that. That's what here our computer systems are the very fast and quicker. It is a technology wise, it is a widely elaborated. Anybody with the touch screens devices also it will be there with the working of the missions. Non-deterministic finite automata, it will be the non-deterministic finite automata will be the it is a quantable, it is a same things of the capital M equal to Q of epsilon delta and Q naught and F, and where it is all will be the defined into the for the deterministic finite automata, it is a delta is a mapping from the one into the another. How the mapping will be there from the two operations into the one operation. That kind of observations also we can study into the in this non-deterministic finite automata. Here, one relationships, it is a how it will be the compound relationships we can be observed. That things we can be learning in this concept. Next, graphs of the NFA, which will be going further, is these are that under that NFA is clearly the two transient labeled A and Q naught. A and Q naught. See here Q naught is started from the A and Q naught. Why? Because of Q naught it starts from the A. It is a two ways. It will be the bifurcated. This is comes to the two transitions graphs. We can be NFA, non-deterministic finite automata. Here, non-deterministic finite automata, it is a transition diagrams also will be the this kind of observations. All will be the failures will be the one side, all will be the passing is the one side. And when sometimes it is of all failures will be the I want to be the one place I want to be located. That kind of observations in the transition diagram corresponding to the non-FSS. Since that is some in our mobile, it is we are using that is some of the components we are not using. Some of the components we are using. In that automata symbols here we are using that is a phone call also dials only. Not only that, we have a plenty of options in the in our mobiles. The plenty of options are not using. What are that? Which situation we are using? That will be the here zeros means it's not using, and the ones means we are using. But it is the compound statements are the one into the another. How it will be the effectively it will working, and where it is the situations are the working. Non-working conditions will be the making into the work condition is the working and working all the conditions into the working. That kind of observations also we can take. This is a state and input. So how it will we should be give. That will be how it will be converted into the binary system and the machine level language into the programmable languages. So that is the total state input strings. So how it will be there. That will be explained by the non-deterministic finite automata. Next, it is coming to the set of strings. It is belongs to epsilon star. It is accepted by an NFA, non-deterministic finite automata. Is called as a language acceptable of a non-finite automata, non-deterministic finite automata. Yes, symbolically representation. It is a Q1 and Q2. So how it will be the given? That is the languages. How it will be the focused? You can see into the diagram. Here he will give that is a state table. Then we can go for the state diagram, and after that it is a how it will be the effectively it will be working. That nature we can be explained. This is the overall idea. Next here another diagram will be there. It is the state conditions of the table he has given. That is how it will be the connected with each other. That they will state diagram we should give and explanation we should give. That is only the important part of there is a non-deterministic finite automata we should be discussed. Next it is a non-automata finite automata. It is a non-determinate finite automata with the epsilon moves. How it will be the moving from the one of the quantified into the another quantified. It with the compound state. With the compound state or without compound state, it is a components how it will be the mixing and moving. That kind of observation. It is a, for example, 2 state and 2 or 3 are all mixing of that. How it will be the movement. We have the total things we can be explained. This is also graphical representations. Here mainly we have a plenty definitions, and these all will be there, and it is important aspect of one short question. And the equation of DFA and equivalence of the DFA and here equivalence means it is one of the automata, finite automata, another finite automata. both will be the when we, both are the equal. That is comes to the languages are the equal we use, and automata what we call components are the same, and one more it is a logical relationships also the same, and set of elements also the same, and expressions are also the same. Then we can say that it is automatically all will be the two finite automatas are the equal. So L of M1 equal to L of M2. These are the conditions we can say that it is M1 be the non-deterministic finite automata, and M2 is a non-deterministic finite automata. See here, transition diagram, if we take this one, and another transition diagram, we can take this one. What are that? Both will be the same, but automatically here with the relationships with the and it is a uses of that interchanges itself. But the both are the conditions are the same. It means that it is one is appears that it's a non-deterministic, another is appears that deterministic. But both are the same. We can say that it is a number of elements and components, and relationships are the same, but is the uses of the insight is with the changes. That is the overall observation of this. Both finite automatas are the automatas and the deterministic and non-deterministic are the equal. Coming to the, this is the most important theorem. Non-deterministic finite automata, then it is a deterministic. This is the same thing. So relationships will be there once you read and remember and write in the exam. This is only the important, main important theorem. One is a 15.4.2. Examples you can see for the 4-mark question. And Morris and Mellis missions, here whether it is accepted or does not accepted in the binary signals. That based on that observations, they have discussed that is a Mellis missions, how it will be the working, and Morris missions, how it will be the working. Here output how we can be represented in the more missionism. That is information we can study here. See here, it is a sequential order representations has given that is a more mechanism in the DFA. And Mellis mechanism, it goes for that is the same delta representation is taking into the input, and output also it is a sequential order it will be are getting. It is a Melli mission is also 6 tuples they use. 6 tuples he used, that is a Mellis, and more he used that is a he is also used it is a 5 tuples. It is a, but here used it is a DFA conditions only. It is a Mellis, you can apply that to both. That is the observations he studied. Yeah, this is the next state and out state. It is a representation, the diagrammatical representation. We can take it here. This is a transition tables for the motion mechanism in the most missions, and the table representation is this one. It will be the connectivities of x cap, x2, cap, x3, like that. It is and the relationships how we can be represented. These are the overall observations that we have in the Morse mechanism and Mellis mechanism. This is also important theorem. All of you remember, recognize this 15.5.8. And this problem also 15.5.9. Once you can check it. It is a simply relationships, how it will be there. Once you check it, automatically you can understand. Okay. Minimization of the finite automata. Minimization of the finite automata, it is a unreachable states and need state or trap states. It is the indistinguishable and non-distinguishable states. These all are the eliminated automata without affecting the language conditions. We can be checked here. From that, it is a which is the path is best reaching to the end of the state. That is a importance logic we have to identify by using the DFA and non-NDFA. This is called as a minimization. Algorithms, we have construction of that. Problems, so they will take that as these are the observations. Okay. Turing missions also the same procedure. It is a read and write. How it will be the effectively look for the tabs of the infinite length. This is the overall observation. One of the Turing mission, how information we can store. Okay. These are our observations we have. Once you can read here, the summary is a DFA, non-DFA. DFA is the thing. Morris and Mellis missions. The things we can be learned here in this unit. Okay. Anyway, time is up, and once all of you read well properly, totally it is a theory only. So basically here, go ahead for the proper sit properly and without any disturbances. If you will read, then you can understand, remember, and you can write the exam. This is only the we can say that. This is only the theory part, so that be cautious and learn the important questions right in the examination. Okay. Anyway, time up, and we will meet in the next session. Anyway, all the best. Amma? Hello? Hello?
సార్
గట్టి చెప్పాలి వాయిస్
ఏం తీరం సార్ ఇప్పుడు ఇంపార్టెంట్ అన్నారు
ఎక్కడమ్మా
తీరం సార్ తీరం ఇప్పుడు
ఎక్కడ
15.5.8
వన్స్ అగైన్
15.5.8 అన్నారు సార్. దాని తర్వాత నెక్స్ట్ ప్రాబ్లం కూడా
అమ్మా ఏది 15 16
15.5.8 థియరం ఇంపార్టెంట్ అన్నారు సార్.
అమ్మా,
అట్లా 15.4.2 కూడా
మీరు చెప్పాలి థీరం నెంబర్ చెప్పాలి.
15.4.2 ఒకటి 15.5.8 ఒకటి సార్.
ఒక్క నిమిషం కమింగ్ బ్యాక్ చెప్పండి.
15.4.2 థియరం ఒకటి ఇంపార్టెంట్ అన్నారు సార్.
ఎస్ ఎస్ ఒక్క నిమిషం బ్యాక్ వస్తున్నాను.
15.4.2 సార్.
అవునమ్మా, ఇందులో లాంగ్వేజ్ యాక్సెప్టెన్స్ ఆఫ్ నాన్ డిటర్మినిస్టిక్ ఫైనైట్ ఆటోమేటా ఎల్ అనేటువంటి ఒక లాంగ్వేజ్ తీసుకుంటే దెన్ ఇట్ ఈస్ ఎగ్జిస్ట్ డిటర్మినిస్టిక్ ఫైనైట్ ఆటోమేటా దట్ యాక్సెప్ట్ ద ఎల్. ఇప్పుడు ఎం అనేటువంటిది ఎన్ ఆఫ్ ద కొన్ని ఎగ్జాంపుల్ సింపుల్ ఎగ్జాంపుల్ ఒకటి చెప్తాను. ఏవైనా కొన్ని ఎలిమెంట్స్ తీసేసుకున్నాను అనుకోండి, ఒక 5 ఎలిమెంట్స్ తీసుకున్నాను. 5 ఎలిమెంట్స్ నాట్ ఇదేంటి నాన్ డిటర్మినిస్టిక్ యాక్సెప్టబుల్ ఎం డాష్ కనుక తీసుకున్నట్లయితే క్యూ డాష్ ఈక్వల్ ఏంటి టు పవర్ 2 దట్ స్టేట్ విత్ ద క్యాపిటల్ ఎం డాష్ సబ్సెట్స్ ఆఫ్ ద సెట్ ఆఫ్ ఎం. అంటే ఈ ఎలిమెంట్స్ అన్ని కూడా సబ్సెట్స్ ఆఫ్ ఎం కింద వస్తాయి. అటువంటి సబ్సెట్స్ అన్నిటినీ కూడా కలిపినప్పుడు ఇనిషియల్ స్టేట్ అండ్ కంబైన్డ్ అంటే నేను మిక్సప్ చేస్తూ ఉన్నప్పుడు అందులో ఎగ్జిస్టెన్స్ అయ్యేటువంటి అవుట్పుట్ అండ్ చివరికి వచ్చేటువంటి అవుట్పుట్ కి సేమ్ ఉంటుంది అని చెప్పడమే ఈ స్టేట్ ఈ దాని యొక్క ఇన్ఫర్మేషన్. ఇది దీంట్లో ఏమవుతుందంటే ఇండక్షన్ ప్రిన్సిపల్స్ యూజ్ చేస్తూ ఒక స్టేట్ నుండి ఇంకో స్టేట్ కి లెంత్ వైజ్ గా ఎలా ఇంప్రూవ్మెంట్ అవుతుంది మాత్రమే చెప్పుకోవాలి. ఒక స్టేట్ నుండి అంటే ఎలా మూవ్మెంట్ జరుగుతుంది అనేది మాత్రము ఇక్కడ రిప్రజెంట్ చేసుకుంటూ వెళ్ళాల్సి వస్తుంది. హలో అమ్మా, హలో 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 అమ్మా, డ్యూ టు ద టైం ఫ్యాక్టర్ నేను మొత్తం ఎక్స్ప్లెయిన్ చేయలేను. అదొకటే లాజిక్. మీరు అందులో ఏంటంటే ఒకటి ఎం స్టేట్ ఎం డాష్ స్టేట్ దాని నుండి వెళ్తూ ఒకదాని కనెక్టివిటీతోన డెల్టా అనేటువంటిది ఏంటిదమ్మా రిలేషన్ బిట్వీన్ ఎనీ 2 ఎలిమెంట్స్. ఆ రిలేషన్ తోన కొత్త రిలేషన్షిప్ వస్తుంది. ఆ కొత్త రిలేషన్షిప్స్ అన్ని ఎలా ఎగ్జిస్ట్ అవుతున్నాయో ఒకసారి చూసుకుంటే ఆ సెట్ ఆఫ్ రిలేషన్షిప్స్ ఎగ్జిస్ట్ అయినటువంటి రిలేషన్షిప్స్ అన్నిటిని కూడా ఒక చోటకి చేర్చుకుంటే R1 R2 R3 కింద ఏర్పడుతున్నాయి. అది కూడా నాన్ డిటర్మినిస్టిక్స్ ఉన్నటువంటివి. అది ఎలాగైనా ఆల్రెడీ ఎం డాష్ అనేటువంటిది డిటర్మినిస్టిక్ ఎలాగైతే ఉందో సేమ్ ఇలాగే ఉన్నాయి కాబట్టి ఇట్ ఈస్ ఎల్ ఆఫ్ ఎం ఈజ్ ఈక్వల్ టు ఎల్ ఆఫ్ ఎం డాష్ అని చెప్పేసి ఇట్ ఈస్ బోత్ ఆర్ ద సేమ్ అని చెప్తాం. అంతే అమ్మా. ఇంకో తీరం మీద అన్నారు
సార్. అది మీరు ఇంపార్టెంట్ చెప్పారు సార్. తను అదే అడుగుతుంది. 15.5.8 థియరం కూడా ఇంపార్టెంట్ చూసుకోండి ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూ అన్నారు.
అవును, 15.5.8 ఇందులో కూడా అదే ఉందమ్మా సేమ్. ఇందులో మెర్లీ అండ్ మిషన్స్ ఇక్కడ నేను అక్కడ 5 యూజ్ చేస్తాను, ఇక్కడ 6 యూజ్ చేస్తున్నాను. ఈ 6 కాంపోనెంట్స్ తో పాటుగా ఇంకా ఏదైనా ఇంటర్ కనెక్టివిటీ రిలేషన్షిప్స్ ఉంటే అవుట్పుట్ ఎలా ఉంటుంది అనే దాని గురించి ఎక్స్ప్లెయిన్ చేసేటువంటి థియరమే ఇది. ఇందులో కూడా ఇది M2 M1 అనేటువంటిది అంటే మోర్స్ మిషన్స్ M2 తీసుకున్నట్లయితే అదే మెల్లి మిషన్స్ కు సేమ్ అవుతుంది. అక్కడ దాన్ని ఇక్కడ 6 కి యూజ్ చేస్తాను. కానీ ఇట్లా కాంబినేషన్స్ అంటే రెండు పార్టీషన్ చేసుకుంటూ వెళ్తే ఎలా వస్తుందో తెలుస్తుంది. థియరీ అమ్మా, గుర్తుపెట్టుకో తప్పదు. హలో,
ఓకే సార్.
ఓకే అమ్మా, ఓకే అమ్మా. మీరు ఓల్డ్ క్వశ్చన్ పేపర్స్ బాగా తరువుగా ప్రిపేర్ అయిపోండి. ఓకే, ఇవన్నీ థియరీ 2 యూనిట్స్ కాబట్టి ఇందులో గ్రామటికల్ గా మీరు థియరిటికల్ గా రాయొచ్చు, ఈజీ ఉంటుందని మీకు ఎక్స్ప్లెయిన్ చేయడం జరిగింది ఈ రోజు 2 యూనిట్స్. ఓకే అమ్మా, ఇదే లాస్ట్ యూనిట్. మీకు ఆల్మోస్ట్ అంత సిలబస్ కంప్లీట్ అయిపోయింది. ఎనీవే ఆల్ ది బెస్ట్ అమ్మా. ఓకేనా?
ఓకే సార్.
ఓకే సార్.